Previously, I've done several videos on the 960 sequencer. These videos included basic operation and even using the 960 as a wave shaper. In this video, we're going to look at a handful of advanced techniques using the 960 sequencer in the context of the Behringer System 55. You're listening to a classic 2 oscillator subtractive voice on the System 55 using the low-pass filter. The first technique we'll explore is using the third row of the 960 to control the internal oscillator timing. This allows you to create a rhythm other than the constant eighth notes commonly used for a sequence. This feature is implemented with the flip of a switch. It's labeled third row control of timing. In this example, I wanted to have note lengths which had either 1 or 2 or 3 beats per note. So for the longest notes, the 3-beat notes, the knob is fully counterclockwise. By the way, the range switch 1x, 2x, 4x does not affect the control CV connected to the internal oscillator. The math required to calculate the knob position was not intuitive for me, so I adjusted the next 3 notes in the rhythm by ear. I used a delay and my ear to fine-tune the timing. So, the first thing we want to do is to turn off the last 4 notes. We'll reset these 3 notes. Just to reiterate, the rhythm we want is 3/8 notes length here, 2/8 notes, 2/8 notes, 1/8 notes. So it's going to be dun 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 dun, and of course it'll loop. So we turn on our third row timing and we listen to what we've got. And we want that to be not 3 notes but 2 notes. And that's very close. Now let's check it against the digital delay. And that's very close. We'll re-enable all these other notes. We'll start at the beginning and we'll listen. And now we've adjusted the third row timing to get the rhythm that we want. If you're liking this video, please hit like and subscribe. Thanks. The 960 sequencer has a total of 3 rows, each of which has a CV value or knob position for each step. So the 960 has 3 parallel rows with a common shift that controls the movement from step to step. With a second 960, you could have 3 additional CV outputs moving in parallel to the first 960 for a total of 6 CV outputs. Alternately, you could have the second 960 shifted at a different rate from the first 960. One of the most obvious use cases for a second sequencer with a different rate is to use the second 960 to transpose the first 960. We'll do that now. I've already set up a series of steps to transpose the original sequence. We need to make 2 connections. We'll patch the step output trigger from the first step of the first 960. We'll use that trigger to shift the second 960 once every 8 steps of the first 960. For the second connection, we'll patch the CV output from row 1 of the second 960 into a quantizer, and out of the quantizer into the CP3AO oscillator controller. I've set up the transpose to happen every 32 steps. Let's reset and listen. So that's the use case for transposing one 960 sequencer from a second 960 sequencer. We're using the 960 internal oscillator as our master clock. Now that our master clock is no longer a series of equal length notes, it would be nice to create an alternate master clock that is slaved or synced to the 960 internal oscillator. We're going to do that with a 921 oscillator. The first thing we'll do is create a simple percussive voice with noise. Got noise going into a VCA and then VCA out. Instead of an envelope, we'll patch the 921 sawtooth output into the control input for the VCA. Let's take a quick listen. All right. The only problem with having a parallel master clock is keeping the two clocks in sync. The 921 has this capability. Here's how we do it. The first thing we'll need to do is tune the 921 as close as possible to the sequencer clock. Typically, it won't stay in sync for more than a few bars. Next, we'll take one of the 960 step V-trigger outputs from the first 960 sequencer. We'll patch that into the V-trig input in the clamping section of the 921 oscillator. Let's listen. With the clamping point knob set to full counterclockwise, it is constantly a few milliseconds off, but it stays off consistently. The same thing happens at the noon position. Once we set the knob full clockwise, it sounds right. And that's how we create an alternate master clock with a 921 oscillator synced to the 960 sequencer. The next advanced sequencer technique we'll explore is the Ratchet Effect. I first heard this effect in the work of Tangerine Dream from the mid-1970s. The idea is to create more than one trigger per step. Typically, the additional notes will create a percussive musical effect. To achieve this effect, we'll use the 921 oscillator as an alternate clock. When we want multiple triggers per step, we'll speed up the 921 clock. We'll use a CV from the second 960 sequencer to control the clock speed. This will give us control of the ratcheting on every step. Up until now, we've used the internal oscillator as our master clock for the 911 envelopes. In order to create the Ratchet Effect, we're going to use the 921 oscillator again as an alternate clock. The 921 pulse output will drive the 911 envelopes. Of course, we'll have to convert the V-trigger pulse output from the 921 to an S-trigger with the 961 interface module. We had to do this with the 921 internal oscillator as well. The gate time on the 961 will be very short, about 45 milliseconds. So this is our 921 output going into the interface for conversion from V trigger to S trigger. I've tuned the oscillator to match the tempo of the internal clock for the sequencer. We'll have to sync the 921 oscillator as we did before with this green patch cable. In order for the faster notes to be heard, the envelopes must be set to an appropriate speed for the multiple triggers per step. I've already adjusted the envelopes by ear for faster decay and release times. Remember, we also used a fast gate time on the 961 interface module when converting from V trigger to S trigger. We'll want control over the number of notes in each step. To do this, we'll use rows 2 and 3 from the second 960 sequencer. We'll clock the second 960 sequencer from the internal oscillator of the first 960 sequencer. The result is that both sequencers will be clocked at the same time, running in parallel. We're using the second 962 sequential switch to allow us to select row 2 or row 3 for our ratchet CV. We can either manually select the row or automatically toggle between rows 2 and 3. This sequential switch CV output will be patched into the 921 oscillator frequency control input. Finally, instead of the master clock from sequencer 1, we're going to use the 921 clock to drive our 911 envelopes. Now that we're all patched up, let's listen to it. I'm going to skip the last 4 steps, start the 921 clock, and start the sequence. So that's how to add ratcheting to your sequences using the 960 sequencer. If you've watched this far, thanks. Please like and subscribe. Also, let me know in the comments if you'd like to see another video with more advanced sequencer techniques. Also, if you have techniques that you use that I haven't included, let me know about it.